All right, so today we're going to talk a little bit about rounding and using significant figures with mathematical operations. So this has to do with kind of the concept of exact versus inexact numbers, because we as scientists care about measurements and values, right? A number and its units. But when we're thinking about an exact value, we don't have to factor in significant figures because it's exact. It's sort of right in the name. So there's a couple different things that we count as exact numbers, and that would be a count. So if I went around and I counted the number of chairs in a particular room, and I said there were 20 chairs, then unless I'm the world's worst counter, then that's an exact number, right? It's not like, oh, plus or minus half a chair. There's just 20 chairs. I counted them all. Another exact number would be a definition. So if you're given some sort of defining relationship, so 1 mole is equal to 6.02 times 10 to the 23rd atoms. This relationship then, these numbers are exact. Okay, so for our count and for a definition, because these are exact numbers, there's no uncertainty in that, right? So if there's no uncertainty, then we don't have to factor them in when it comes to significant figures. I don't know what happened to my D there, but don't factor it in for the significant figures because there's no uncertainty that's associated with them. Inexact numbers, on the other hand, are things like your measurements. So anything that we do in the lab, they are calculations, right? So calculations usually come from measurements. These are all inexact values. And these measurements have some uncertainty that's associated with them because of the precision and accuracy of our measuring tools. So I'm going to say that the Sig Figs matter here. Matter. Okay, so we have exact versus inexact numbers, and this is going to matter once we get into kind of thinking about this in terms of rounding. So let's think about this in terms of mathematical operations here. If I said, well, how much do 10 chairs weigh? Right, and weight is, of course, a force. It's not a mass. So I'm going to talk about their weight in terms of pounds. And let's say I went around and measured, and I found that the average chair, one chair, is roughly 7.2 pounds on average. So I did a very highly scientific study. I went around, I measured the weight of a bunch of chairs, and the average value was 7.2. So the 7.2 pounds then, because it's measured, because it's something that I determined in some way, shape, or form, this is an inexact number. So just like any other kind of mathematical problem like this, and this looks like just kind of a basic algebra problem, if I have 10 chairs and each chair is 7.2 pounds, right, then my chairs will divide out. I'll be left with an answer in pounds, so I end up with 72 pounds, right? That's the way that we would do this mathematically, and this is called dimensional analysis, is the way that I'm setting this up here, or the unit factor method. So my chairs divide out, I'm left with pounds. 10 chairs, though, is a count. I counted up 10 chairs, and because I counted it, it's exact. So this is inexact because it's something that I measured, right? On average, I have 7.2 pounds for every one chair, but the 10 chairs themselves, that's an exact number. So when I'm looking at these two values to determine how I'm going to round my answer, the rounding of my answer will be dependent on the significant figures of my inexact number. And you might have more than one. So we'll put numbers in there. It's number, not hashtag. So it depends on the significant figure of the inexact numbers that are in your overall mathematical equation. If you have more than one inexact number, then you're going to have to factor in multiple, and we'll get to that. Okay, so that's kind of the idea here. We have exact numbers, we have inexact numbers, and when we're thinking about doing mathematical equations, then the way that we round our answer is going to be dependent on the numbers that we put in to the math. So with rounding in general, the rules of rounding are the same as we've seen since elementary school. So if we have 5 and up, we round up, and if we have less than 5, then we round down. But when we're rounding, we want to round to the correct number of significant figures, and so there's certain rules depending on the mathematical operation. So let's talk about the rules of math and significant figures. The rules. Okay, so the rules for significant figures depend on the mathematical operation that's being performed. So in multiplication and division, so if I'm multiplying or dividing, I'm doing a product or a quotient, then the answer that is spit out at the end of that mathematical operation has to be rounded to the number of significant figures of the least number that you put in. So we'll call that the least precise value because that's the one with the fewest number of significant figures. So if I have something that looks like this, and I'm just going to do straight numbers here, not values, then when I take 2.50 and I multiply by 1.4369 and I plug it into my calculator, then my calculator says, well, that gives me an answer, 3.59225, right? And maybe in a math class, that's the answer that you would put, right? If it didn't give you any information about, well, round to this many places or whatever. But when we are talking about values, then we're talking about applied numbers. These numbers have physical meaning. Maybe they're a length, maybe they're a mass. And if they're things that I've measured, then I have to factor in the number of significant figures in each in order to round my answer to show the least precise measurement that I made. I can't have an answer that is more precise, right, that has more significant figures than my least precise value. So let's look at each of these. If I look at this first number, how many sig figs does it have? Well, I have 2 non-zeros, and because this 0 is after a decimal point, it is also significant, so I have 3 sig figs. In this one, I have all non-zero numbers, decimal or no decimal, it doesn't really matter. It's the zeros that kind of muck everything up. So that would be 1, 2, 3, 4, 5 sig figs. So the rule is that I'm going to round my answer to the lowest number of significant figures that I'm plugging in to get that answer in the first place. So 3 is my magic number then, because this is my lowest. So I need to round this to 3 significant figures. So I start from the left and I say, well, 1, 2, 3 of them are significant. All 3 of these decimal places are significant. So then I look to the next digit as my rounding digit. Regardless of what comes after that, it doesn't matter. This is what I'm looking at to round this next number up. So 3.59 are all significant. 2 is my rounding digit. So just like we learned in elementary school, it's less than 5, so we round down, which means we keep this place the same, and our answer would be 3.59 with 3 significant figures. Okay, doing okay so far? Let's think about addition and subtraction then. Now with addition and subtraction, it's a slightly different rule, although it means the same thing, because we're still thinking about precision of our measurements and the least precise and the least precise values, how that impacts the rounding of our answer. But with addition and subtraction, instead of looking at the least precise value, the one with the fewest number of sig figs, with addition and subtraction, we're looking at the lowest number of decimal places. So we're going to round our answer to the number of decimal places as the value with the fewest decimal places. Now this rule is always hard to kind of capture in language. I think it's easier to see if we actually just kind of look at it in practice. So if I have a series of numbers, again, I'm not going to give you values here, I'm just going to give you numbers until we start to get into real problems, just for showing the concept. Okay, so if I add 3.4, 1.29, and 5.519, and I plug it into my calculator says that the answer to that is 10.209. And my calculator doesn't know significant figures rules, but I do. And these numbers, if they have physical meaning, show the precision of my measurements. If this is a length, then I think that it's somewhere between 3.3 and 3.5 of whatever units I'm using, meters or inches or whatever. So we're going to round our answer to the number of decimal places as the value that I've put in that has the lowest number of decimal places, which hopefully we can see right off the bat is the 10th place here in my first number. So my first number has a 10th place, my second number has a 100th place, my third number has a 1000th place, so I'm going to round my answer to the 10th place. So I'm going to cut it off at the 10th place, because that's as far as I can go, regardless of anything that's on this side of it. I could have a zillion numbers in front, but if I have a 10th place here, and that's the fewest number that I have past the decimal, then I'm going to round this thing to the 10th place. And then I'm looking at this next digit as my rounding digit. Now again, with our rounding rules, that is lower than 5, so it's going to round down, which means that I keep this number the same. So my final answer is going to be 10.2. 10.2 has 3 significant figures, which is a greater number of significant figures than the lowest number of sig figs here, but it is the same number of places past the decimal. Okay, so in addition and subtraction, it's all about the number of decimal places, whereas with multiplication and division, it's all about the least number of sig figs along the way. So it's important to keep those rules straight when we're doing mathematical equations, and it's important when we're practicing then to always practice using good significant figures in our answers. That's going to be very important moving forward.